let's now look at the C++ equivalent of the BMI. And what I've done here is I've replaced the word struct for class and made a few more changes. So your basic properties, your data, are here. And notice I put an underscore on the front purely to remind me that these are not things you would access from outside of the class. They are what's called private. Okay, and we'll explain and show what that means in a minute. The API, the set of functions which we want people to use, are listed here, and they are public. So that means that people consuming this class and reusing it can access these. And I might have private methods down here as well, functions, if you like, down here, if I had it. Okay, so this is the class declaration, but you'll notice there's no code. There could be, but I chose not to put any in here. And it's just function prototypes, right? We're just describing them, declaring them is the proper word. This one's a bit unusual. It's a function with the same name as the class, and that's called a constructor. So all of this is in chuman.hpp, and its sibling is chuman.cpp. This is where the code goes. So we include the header file, and then we write all the APIs, all the functions in here, both private and public. And we know they're functions from the class because they all have this prefix, this name prefix, chuman : : If you miss that, they're just ordinary global functions and have no access to the private data members. So this, the fully resolved name, is actually, in the case of display, chuman : display. Right? So if there's another display function written by somebody else, that's not the same. That's a different name. Yeah. Now we only, well, you'll see that we don't have to always write this on the front, but we'll come to that. All right. So before I sort of explain these, let's go and look at an example of using it. So imagine that this is written by someone that did not write the class. They just got some documentation. So let's look through it. chuman, that's the data type. Person1, and these are the parameters that we initialize with. And we might display it. Then we create another one and display. And then I then change the weight of that person too. Notice I don't directly change the variable because I can't. And then I display, etc. If I want to extract the individual members, I have functions to let me read them. Note the braces there, that's a function, a public function, and I can write that out. What I cannot do is access the data directly. If I try and compile that, it says it's private, you can't have it. Okay, so just to remind you then, age, weight, height, BMI, and this special one I've created for optimization, if you like, these are all private and you cannot access them from outside the class. So that enforces one of the fundamental issues with encapsulation, that you don't want other people messing around with the internal state of your component. Right? So if you built a chip, you give them a set of pins and a data sheet, that's your API if you like, you don't want them accessing the internal stuff, you deal with all that. They just need to know how to use this. And so C++ lets you enforce that, just like you would with an electronic device. Okay, but we've solved a few more problems, not just that, the problem with initialization, for example. So let's try and create a human without initializing it. All right, Fred. I'll try and build it, and it says, oh, can't do that. Now I mentioned a thing called a constructor. Okay, now I've written a constructor that takes 3 parameters, and in effect what I've done is I have forced the user to provide 3 parameters. There's no other way of creating something of this type unless I provide the 3 parameters. And we see that in embed, for example, with things like digital out, where you're forced to provide a pin. Okay, there's no way around it. All right, So let's actually step through this code now and actually see this in action and how it works. So very often you will be provided with objects like this, and you'll only get the header file, and there's no code in there, but you can see all the properties and all the APIs, and that's absolutely fine. What you can't see is the implementation, and you may not wish to unless it's open source code. So the first one is declaring a person 1 as type C human and passing parameters. Now, passing parameters is something you normally do with functions, and that is because this calls a function. Right? It may not be obvious, but it does. So if I step in with my debugger, sure enough, we've stepped into a function, and look, it belongs to the class. Right, now if we look at the declaration, it's this one here. Right? It's the special function with the same name as the class, and when you do that, you've created a constructor, and this is always, one of them is always run and only once. So notice it's asking for 3 parameters, and this convenient syntax lets me initialize my private data underscore age with the one you provide, and same for weight and same for height. And just to contrast it, I've also put in the needs update and initialize that as well. Now notice I've left in on purpose here this and the pointer dereferencing thing. If you remember with structures, the first parameter I always passed to my APIs was the address of the variable that I want to change and read. Okay, exactly the same thing is going on here, except it's hidden and it's always got the same name, this. So for ordinary member functions, you've always got the address of the current variable that you're referring to, and it's this instance. That's what it means. So we don't actually have to write it every time. I could have just put underscore needs update equals true, but I left this in just to show you that that's all this means. Okay, this is just the address of the object we're modifying, just like with the structures. So carry on. Step around that. Now let's have a look at display. Now I haven't calculated the BMI yet, and I'm already trying to display it. So is this a bug? Well, let's have a look. Step in. So we print out, and notice what I've done. I printed out float, 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 weight, height, and I've called the function BMI, which is down here. Now, BMI is public. I could have made it private, but it's not a problem. I haven't accessed BMI, the variable, directly. In fact, arguably, I don't even need it, but the way I've done it, we do, and you'll see what I've done. So I'm going to print out weight colon, height colon, body mass index colon. I read the weight, because we know that's been initialized. We read the height, because we know that's been initialized. And we're going to print out whatever floating point value is returned from this. Now this is a little bit more involved, as you'll see. I'm maybe trying to be a bit too clever for a first example, but bear with me. So let's step into that. It's a member function because it's got this on the front, so it has access to all the private data. Right? Only member functions do. And I'm checking, does needs update equal true? Well, in the constructor I said it was equal true, yeah. And that's because we need to update the value. We haven't calculated it yet. All right, F6 step. Now, because I haven't calculated yet, look, it's calculating the BMI, and now sets needs update to false because it's all up to date. The parameters, the weight and the height, now match the BMI. And now I return the BMI value, a copy of it, and we print it out. And there it is down in the terminal. Okay, and then I do the little thing with the asterisk, and we're out. Now what will be interesting to do actually is to show you what happens the second time round. Person1.display. If I was to call it again, you'll see that the calculation is only needed to be performed once because I've added that feature. So we've done it once, we've displayed it, there it is at the bottom. Let's go in a second time. Now, step in. Does it need updating? No. so it just returns the value. So I haven't bothered recalculating it because multiply and divide is relatively expensive. It's up to date. Don't need to do it. So that's the sort of thing you can get with abstraction. Yeah, if you were to put that code all throughout your software everywhere, you're going to have bugs and it's going to be difficult to maintain. I've managed to be a little bit smart, if you like, about this because we're hiding it all away in functions, and the user never needs to know about it. So the first time you call display, it's a little bit slower than the second time. All right. Assuming the data's not changed. So there you go, same value comes out, even though we didn't need to recalculate it. We didn't. Now we create a second one, display, and it's got a star on it because that value is a little on the high side, relative term. This is not supposed to be in any way representative of anything medical, it's just an example. Alright, so we suggest cutting out the beer. And then what I'm going to do, I'm going to update the weight. Now if you remember in the very first example, this is hazardous because if I update it and forget to recalculate it, I don't get an updated BMI. Alright? So obviously if I'm going to update the weight, the BMI needs updating as well. Aha! This again is the benefit of encapsulation and writing an API. Right, in we go, let's have a look. So we get hold of the weight, update the internal value for weight, right? The member function can do that, no one else can. And I set needs update to true because now I'm saying BMI is out of date, but I'm not actually going to calculate it. I could have, but I'm again trying to be a little bit too clever here maybe. I'm just flagging in a very quick operation BMI is out of date. Because who's to say they're actually going to display it? Right? Imagine that was a calculation that took 2 minutes. Obviously this one doesn't, but it could be. We're not going to do it unless it's actually needed. So I've just flagged that now the BMI value is basically stale. And I am going to now show you what I mean. So I've updated the weight, but I haven't recalculated the BMI yet. But I've made a note. So let's go and have a look at display. Step in, needs update. Yep, it's true. Because we're trying to display it and it's out of date, we recalculate it. Right? And so forth. So you can see that the encapsulation here has not only made this safe, because you've got to use the APIs. There is no other way to use this class. It's also allowed me to add efficiency, okay, in avoiding unnecessary calculations and safety by making sure they do actually occur when you actually need them by encapsulating inside a class. Okay, so we can also read back the values. Now, whoops, I stepped over that. Let me go to that again and I'll show you what that does. So, as I said, you can't access the internal height and weight and BMI directly. Doesn't mean you can't read them, we just don't want people modifying them. So the way to provide a read-only access is to have a function, note the brackets, step in. Look, it just returns a copy of the height. It's a copy, yeah? You can't modify the original via this, absolutely no way. Alright, so H2 is an independent copy of the height. If I modify H2 now, it won't affect the original one. So making it safe. You can write it out. And just to re-stress a point, let's say someone did try and modify the original height. Well, if you build it, it says height is private. I'm not even going to let you run. So there you go. That's encapsulation with C++.